So in this video, we are talking about how we learn about functions from graphs. In other words, we are determining specific things about the function we're dealing with based on the graph of that function. For example, we'll have a problem that looks like this. We have a graph and then we have lots of questions that will help us determine things about the function. So let's get started. In part A of this question, we are asked to find the function of 0, the function of -6, the function of 6, and the function of 11. To do this, you must first know that the function of x equals y. In other words, the number after the f is our x value, and we look at our graph to determine the y value, or the function of that number. When we look at the graph, we're going to be looking for x equals to 0 and where the y value of that is. So if we look here at 0, that's our x value, and we go up to where the y value is of that number, and we see that it's 3, then that means the function of 0 equals 3. And you do the same thing with the other numbers. So we're going to go to our point there at -6, and now we're trying to find the y value that corresponds to -6. If you look right at our graph, we have -6, -3. So that means our y value is what we're looking for. So the function of -6 equals -3. Then it's asking us to find the function of 6. So we go over to +6, and then we look for the corresponding y value, and that happens to be 0. So the function of 6 equals 0. And last but not least, we're looking at the function of 11. So we go all the way over to our x value to equal 11, and we go up to the corresponding y value, and it's at 1. So the function of 11 equals 1. In the next part, we are asked whether or not the function of 3 is positive or negative, and whether the function of -4 is positive or negative. So you use the same process as above. We're looking at our graph. So we go to 3, because that's our x value, and we look up to see where, or down, depending on how our graph looked. But in this case, it's positive, because if we went up to a corresponding y value, although we don't know what it is, somewhere between 3 and 4, we know that it's positive. So function of 3 is positive. And the same thing goes for the function of -4. So we go as that being our x value. We're going to go to -4, and we're going to look for a corresponding y value. And of course, again, we don't have an exact number, somewhere between 0 and -1, but that number, no matter what it is still negative. So the function of -4 is negative. Alright, next we're asked for what values of x is f of x equal to 0. So here we just look at which x values belong with a y value of 0. So it's sort of the inverse of what we were doing before. So we're looking for any y values that are equal to 0 and which corresponding x values belong with those. So if we're just looking at our graph, we can see that there's a point here that has an x or y value of 0, here and here. So now that we've found those points where the y equals 0, we're just looking for the x value. So for what values of x is the function of x equal to 0? Well, we can see that that would be -3, 6, and 10. Okay. And that goes for any number, not just 0. So if the function of x equaled 3, we'd look for the y value of 3, or any points that had that y value, and find the x value of that. So in this case, we can see that there's a y value of 3 here and here. So if we were looking for the function of x equals 3, the x values would be 0 and 4. Alright, part D asks for the domain of the function. Here we are looking at the span of the graph horizontally, which would be just side to side. With that in mind, we can see that the domain goes from -6 and it stops at +11. So easy enough, our domain is -6 to 11. In the range, if domain is horizontal, then range is just the vertical span. So from the graph, if we're looking this way, we can see that our lowest point is at -3, and the peak of our graph is at 4. So the range of the graph is -3, +4. Next, we are asked about the x and y intercepts. So you can basically just look at the graph and look at your axes to determine where the graph crosses each axis. So here we can see that the x-intercepts, if the graph is moving upwards here, it crosses here, crosses at -3, keeps going, hasn't crossed back down yet, and then it starts moving back down and it crosses at 6. We keep going steadily down and then suddenly we move back up and it crosses at 10. So easy enough, the x-intercepts are -3, 6, and 10. And the same thing goes for the y. You just follow your graph and see where your graph crosses the y-axis. And here we can just see that it crosses at 3. Okay, 2 more questions left. Now we're asked, how often does the line y equals 1/2 intersect the graph? So we know that when we just have a y value equal to a number, that it's going to be a horizontal line. So we just take like 1/2, a point on the y-axis, and if we had an imaginary line here, you can, and start it over here, you can see that it crosses once, keeps moving, then it crosses again, crosses one last time. So you just kind of have to either draw a line or just picture a line there, and you can see that it crosses 3 times. And then the same thing goes for x. So we're asked, how often does the line x equals 5 intersect the graph? So then we look for a vertical line because that's what x equals. So we go to our x equals 5, and if we drew a vertical line here, you can see that it only crosses the graph one time, which is good because that way we know for a fact that it's a function, because we can tell from the vertical line test that if it crossed one more time, then the graph we're looking at isn't a function. So it's good news that the entire time we've been doing this is actually a function. So it crosses once. And that is how we determine things about functions from their graphs.